This lesson is on parallel and perpendicular lines, and there's quite a few definitions and some theorems that we're going to learn. So make sure you're using your notes. Pause the videos when you need to write these things down. So the first two things are parallel and perpendicular lines. And I know we've studied these before, but parallel lines are coplanar lines. That means they lie within the same plane, meaning a flat surface is a plane. It's a two-dimensional flat surface. And these little arrows on the lines denote that they are parallel. That's how we know on a drawing if they are parallel. Perpendicular lines are coplanar lines that intersect to form 90-degree angles, and 90-degree angles are like this little box. So they're perpendicular lines and they form right or 90-degree angles. So make sure you understand that. Okay, so the shortest distance theorem. Let me move this over just a second. Shortest distance theorem says that the shortest distance from a given point to a point not on the line is perpendicular. So if we have a line here and a point somewhere out here, the shortest distance from C to this line, if we drew that and we tried to make it as short as possible, because notice if we went like that, that's going to be a longer line, that's going to be a longer line. Those are all longer. So this shortest line is going to be a right angle. It's going to be perpendicular and form right angle. And here is the proof of that. I know they walked you through it in your instruction, but just make sure you understand that some of these things, these terms like unique line postulate, that means if we draw a line from here to here, we can draw one line that will do that will intersect it at a certain point. We can decide what's the definition of a right triangle. The hypotenuse, remember, is the longest side of the triangle. And so that's the proof in case you need to understand that. So the parallel postulate, so this one is the shortest distance. If we have a point in a line, the shortest distance is a perpendicular line. The parallel postulate says if you have a line and a point not on the line, then there's only one line that we can draw through that's going to be parallel if it's in the same plane. So if we're on the same surface, if we draw a line through that, it doesn't matter how close we try to get, there is going to be only one line that is parallel. Skew lines, this is another definition you need to know. Skew lines are they're non-coplanar and they do not intersect. So if you look at these two planes right here, so R is a plane and W is a plane. It's like you have two sheets of paper that are one's above the other. And if you have two lines in those planes and they're going in different directions, they're never going to intersect because they're only going in this two-dimensional plane. So those are called skew lines. Lines where R and W are parallel planes, then DE and FG are called skew lines. So that is when we're looking at non-coplanar lines that do not intersect. So if we have lines in 3 dimensions, we can either have parallel lines, perpendicular lines, or skew lines. So let's identify the parallel lines. So if you'll notice, we've got these little markings that show us that P and M are parallel because they're both in plane A. So we would say P is parallel to M. This little symbol shows parallel. And they are both in plane A. Then we can say perpendicular, we've got L and we've got N that are perpendicular to each other. So they form a right angle. So we say L is perpendicular to N. Now what about skew lines? Are there any skew lines? Well, if you take a look, if we look at this plane A and this plane B, notice P and L are in different planes and they're never going to intersect. P is going to keep going this way and L is going to go vertically like this and they will never intersect. So those would be skew lines. So P and L are skew, and also M and L are skew because they also are never going to intersect. They're in different planes. This plane is just kind of going. So 3-dimensional, sometimes it's hard to visualize, but that's what skew lines mean. Now N, because it's in that same plane as A, they're actually going to intersect with those. So it's not skew. So which are lines that will intersect? Which lines are going to intersect? So pause this video and see if you can try to determine how this is, and then we'll walk through it. Okay, lines that are going to intersect are A and B. And why is that? Because they're in the plane M. Both of them are in the plane M and they're not parallel. You can see if we keep going with A and keep going with B, they're going to intersect. So those will eventually intersect. intersect, which are perpendicular lines, B and D. So notice we have this right angle right here. So D and B are perpendicular lines. And which are skew? Well, C is in this plane N, and A is in this plane M. And so those will never intersect. The same could probably be said too for C and B. Those are not going to intersect because they're in different planes as well, but I don't think that was one of the options you could have chosen. So here's another theorem. You want this in your notes. You want to understand this. This is going to kind of be the basis of a lot of the things that we're going to be doing. So the perpendicular bisectors theorem says that if we have the points on a perpendicular bisector, so perpendicular bisector, there's two words there. Perpendicular means it forms a right angle or 90-degree angle, and bisector means in half. It cuts it in half. So a bisector, if I cut something, if it's a bisector, that means this side is equal to this side. And that's what these lines denote. So this is a perpendicular bisector of segment QR. And what this says is that the points on any point on this line, wherever we choose, if we choose this point up here and we make a segment to the endpoints, those are going to be equal. If we choose a point here and we draw segments to the endpoints, those would be equal to each other. So, and as we move this down, obviously any point we choose and we make a segment, they are equidistant. They could be equal to each other. So however you do that. So here's again something that's just so you can be aware of, but if you have C and you've got a perpendicular bisector, L is a perpendicular bisector, so it forms a right angle and it cuts AB into two equal segments of AD and DB. So we want to prove that AC is equal to BC. We want to prove this theorem. So by the unique line postulate, you can only draw one line, one segment BC. So it's saying you can only draw one segment BC, and then you use reflection to reflect that across the line to AB. And so by reflection, you know that those are equal. So we're reflecting A over to B is equal, and since reflections are equal, then the lengths are equal. So that, if that, you like to learn proofs, but that's a good way to understand what's going on. So now we want to apply the perpendicular bisector unit. And the way we do this is, what is the length of segment SR? So we have SR right here, and we have SQ. Well, we know those are equal. So to solve, we're going to set 2x plus 8 is equal to 8x minus 4. And we solve for x. So we're going to subtract 2x from both sides and add 4 to both sides because I'm trying to get the constant on one side and the variable on the other. And I divide by 6 and I get x equals 2 units long. And so then x is 2 units. So if we substitute that in, 2 times 2 is 4, 4 plus 8 is 12, and 8 times 2 is 16, 16 minus 4 is 12. So those are equal. So the converse of the perpendicular bisector theorem is the same. Converse means the opposite. So it says if the points are equidistant, then it's on the perpendicular bisector. So if I have a line and I have a segment right here, and I say, well, that is definitely not a bisector. Let's try that again. And let's say I know that this is equal to this. Okay, so this point right here, and I draw a segment here, and I draw a segment here, then I know that that point is on the perpendicular bisector. So if they're giving me that these are congruent, then I can say, well, that is a right angle, and those two are congruent as well. So here is a part, you just want to pause this and take notes so you understand these. So perpendicular lines are in the same plane and they intersect at right angles. Parallel are the same plane and never intersect. And skew lines are in different planes, but they never intersect. We've talked about the shortest distance theorem, meaning if we have a point and a line, the shortest distance is going to form a right angle. It's going to be perpendicular. The parallel postulate says if we have a line and another point, there's only one line that can go through that is parallel. The perpendicular bisector theorem says if we have a segment and that is bisected perpendicularly, so if we have this and this, then any point on that perpendicular bisector is equivalent. And the converse says if we have two sides that are equivalent, that point is on the perpendicular bisector. So let's erase all this here. Let's find segments CD and AB. Well, CD, because this is a point, this is a perpendicular bisector, so we know that if 32 is AD, then this one is also 32. And how do we find AB? Well, we know these two are congruent, so they're equal, so 28 and AB equals 28. So let's practice this. Use the diagram to complete the segments. Segment AD must be congruent to which segment? Well, AD is on, this D is on the perpendicular bisector, so and A and C are endpoints. So AD must be congruent to DC. And AB, or BC, and it's already marked, must be congruent to AB. What do you know about AE and CE? They are also congruent to each other because they are also, E is also on the perpendicular bisector. So let's look at them in 3 dimensions. Are the lines in the diagram perpendicular, parallel, skew, or none? So I want you to pause the video and see if you can identify these. If you notice, L and M are in the same plane. They're both in plane A, but they're not perpendicular and they're not parallel, but they will intersect. So they're none of those. They're not perpendicular, parallel, or skew. L and N are in different planes, so they're not going to intersect, and so they are skew. And M and N are perpendicular. They form a right angle. So let's do some solving here. The length of TR is 17 units. So TR right here we know is 17, this line right here. So how are we going to find SV and QT? Well, we can find, what do we know? First of all, we know 17, TR is congruent to RV, and so we can find the value of X. Once we can find the value of X, then we can substitute it into these other values of X and then find out what's congruent. So let's do this part first. We've got 17 equals 3X plus 2. So 15 equals 3X after I subtract 3 from both sides, divide by 3, so X equals 5. Once I know X equals 5, then let's see, SV. Well, SV is right over here. Which line is congruent to SV? Well, it would be this one over here, right? So if we can find out what ST is, then we know SV, and we just found what X is. So all we need to do is say 9 times 5 minus 4 equals, what is that, 41. So SV, so T is 40, or ST is 41, so that means SV is also 41. And then QT is this side over here, and it is congruent to QV. Well, QV is 4X plus 1, so we say 4 times 5 plus 1 is equal to 21. So if QV is 21, then QT also needs to be 21. So 41 and 21 are those things. So just take a look at what you're given and solve from there. So hopefully that gets you started. If you have questions, let me know. But make sure you get those things in your notes that you need to know.